So here's another question that we have. This question says a power generating station has the following data. Install capacity of what? Of 300 megawatts, and we have the capacity factor of 50%, annual load factor of 60%, annual cost of fuel and oil etc of what? Of 90 million naira. So it says the capital cost of 1 billion and the annual interest and depreciation of 10%. We are to calculate the what? We are to calculate the minimum reverse capacity of the what? Of the power generating station. So to find the reverse capacity, we are just going to first find the capacity factor. So what is capacity factor? So capacity factor formula is the same thing as what? It's the same thing as average load. Average load by what? By the installed capacity. So the next thing that I'm going to do, I'm going to find the average load. What is average load? To find average load, so I'm going to make the average load subject of the formula, and at the end I will have the capacity factor multiplied by what? Multiplied by the installed capacity. Let's say it is IC. So what will be our capacity factor? So capacity factor, it is 50%, because from the question says the capacity factor it is 50%. So I'm going to convert it. It will become 0.5 multiplied by what? Multiplied by the installed capacity. So what is the installed capacity? Our installed capacity, it is what? It is 300, because from the question we have installed capacity of 300 megawatts. So therefore I will say multiplied by 300, and at the end it will now be equals to 150 what? Megawatt. So the next thing, I'm going to find the maximum demand. So you have to keep this in mind. So what will be the maximum demand? Maximum demand, the formula, we are going to use the load factor, which is the same thing as the average load divided by what? By the maximum demand. So if we make the maximum demand as the subject of the formula, at the end I will get the average load, which is this average load by the load factor. So I will say load factor. So you have to take note of all the formulas. So I'll have, what will be the average load? Average load, it is what? It is 150, because this is the solution that we find. So I will say 150 divided by what? The load factor. What is the load factor? This is load factor at 60%. So we are going to convert it. It will become 0.6. So at the end I will get 250 megawatt as what? As my maximum demand. So the next thing, I'm going to find the reverse capacity of the power generating station. So as you can see, the reverse capacity, it is the same thing as, let me say this is reverse capacity. It is the same thing as what? As the installed capacity minus the maximum demand. So this is the same thing as what? What will be the installed capacity? As you all know, the installed capacity, it is the same thing as 300. So this is the installed capacity. This is 300 megawatt. So it will now be 300. So I have to subtract it by what? By the maximum demand. My maximum demand is 250 megawatts. So I will say 250. So this should now be 50 what? Megawatt as the final solution of this. So the next thing, I'm going to find the cost per kilowatt generated. So now to find the cost per kilowatt hour generated, I'm first going to find the total energy that is generated per 1 year. So you have to take note that the average output, let me say this is average output. So the average output is the same thing as what? As 300 multiplied by what? Multiplied by the 50%. And at the end is the same thing as 100 and what? And 50 what? Megawatt. And therefore I have to find the hour in a year. So what is hour in 1 year? Hour in a year is the same thing as 87660 hours. So I have to find the energy. By energy, it is the same thing as this average output multiplied by what? Multiplied by the hour in a year, which is 8760, and at the same time it will now become equals to 1,314,000 what? Megawatt hour. So I have to convert this to what? To kilowatt hour. So to convert it, I'm just going to multiply it by 1000. So after multiplying it by 1000, let me say convert it to what? Convert. I'm to convert it to kilowatt. Let me say kilowatt hour. So this is the same thing as 1,300,000 and what? And 14,000 multiplied by 1000. So at the end I'll get 1,314,000 what? And 14 million kilowatt hour. So the next thing that I'm going to do, I'm going to find again the total cost per year, which is the fuel cost and the fixed cost. So let's find the total cost per year. Let's first find the fuel cost. So the fuel cost, it is what? It is 90 million because it says the oil etc of what? Of 90 million. So I have to say naira, which is 90 million naira. And also the fixed fuel, the fixed cost, it is 10%. 10% of what? Of 1 billion. So this is what? This is 1 billion. Capital cost of 1 billion. So therefore this is the fixed cost. So I'm going to find the 10% of 1 billion naira. So I have to say 1 billion. So the 10% of 1 billion is the same thing as what? As 100 million naira. So I have to say 100 million naira is what? Is the 10% of what? Of 1 billion. So now the total should now be equals to what? Should now be equals to 90 million plus what? Plus 100 million. It is the same thing as what? It is the same thing as 100 and what? 190 million. So the next thing that I'm going to do, I have to divide the cost by what? By the energy. If you could recall, I find energy which is what? Which is almost 1,314 million naira. So then I will now say the cost. If I divide it, so I'm going to divide the cost by energy. So therefore the cost per kilowatt hour, it is the same thing as what? It is the same thing as 100 and what? 190 million divided by what? Divided by the energy. So the energy, it is almost over 1,314 million naira. So at the end, this will now be equals to 0.145 naira per what? Per kilowatt hour. So this is the cost per what? Per kilowatt hour generated. So this is the second question that we solved.